All right, so I had already welcomed everyone and done a little introduction. So the students who were in attendance right now were reading the whiteboard. So that's for those who are attending the lecture live. I am recording it for those of you who had a conflict and could not attend the live lecture. So I'm going to take you over to the desktop. So your screen right now is changing, and so right now you should see my Stat Lab. Okay, last night I checked and I didn't have a lot of you registered. So let me check right now. The reason I'm doing this is because I want to show you that there is an assignment for you that's due today. It's a survey. I emailed it to you. And it's also on my Stat Lab. Okay, so I have 37 of you on here. So you still have to get on, most of you still have to get on my Stat Lab. And this is what it looks like. Okay, so I'm going to click on Announcements. And that's where the survey is. All right, so under Announcements, it says Survey Assignment. If you haven't taken the survey, you need to make sure you click on that, and it's a very quick 2-minute survey or a minute survey, and then you're going to submit that. All right, so there's someone who can't hear me, so I need to type out what he needs to do. Okay, you can hear now. Okay, perfect. All right. So if this ever happens to you where you can't hear me, at the very top on the upper left part of your screen where it says File, Edit, View, Tools, right above the video portion, look at Tools. And when you select Tools, it gives you a drop-down menu. Then there's Audio. And then there's that audio setup wizard. And so you have to set up your output device and your input device. So whatever it is on your computer, you need to make sure you have the correct output device. Now, I'm not having students do a microphone, because what happens is not everybody has a noise canceling microphone, and I hear all the background noise and everybody else hears it too, so it's really distracting. However, at the break, if you have a question and you don't want to type it out, or towards the end of the class, if you rather just talk to me, then I can give you privileges to the microphone, and then you can just talk to me. Okay? Of course, those of you who are watching the recorded lecture, you cannot participate. So those of you watching the recorded lecture, if you're trying to type out a question in that chat area, you can't do that. All right? So you cannot participate in any possible way. So that's why attending the live lectures is the best, because you could stop me, you can ask for another example. You have more control of what's going on. Okay? All right, so everybody right now has the website on their screen, correct? The Spring 2015 Online Math 160 course. Good. So when you click on the survey, and that's what I'm doing right now, that's what comes up. Now, I'm only asking you for your first name and last name so I can give you credit. Once I've given you credit for this, I'm just going to go ahead and delete your first name and your last name. So the data that I'm using is anonymous. It doesn't matter. I don't want to show who it came from. So it'll be, once the data is anonymous and the names have been cleared, we're going to use that data to look at descriptive statistics. So please, please fill out the survey. Otherwise, I will not have data to work with. I did give you a deadline of today, I believe, 11 p.m., I think it was. It's on the announcements. Let me read it. So yes, today is January 26th, and it says 11 p.m. And I try to always stick with the same time for all of my assignments, 11 p.m., and that way it's just easy to remember that. Our assignments have due dates of Mondays and Wednesdays. If you go to your homework, you'll notice that all of the due dates are Monday or Wednesday due dates. I only do that because then it's already a given. If it's a Monday or Wednesday, you know something is due. This is feedback that I got from students a few years back because my due dates used to vary. You had to log in to see what assignments were due. So I had suggestions, and I used a lot of those suggestions from previous students. And one of them was the due dates for homework. So Monday, Wednesday, you always know when something's due. You don't have to log in. You already know you have to turn something in. On the syllabus, it already told you that this website, we will have trouble with it. I mean, sometimes it'll be slow. Sometimes it'll be you won't be able to log in. I mean, there are going to be issues, and that's just part of taking an online class. I already know that we're going to have technical issues, and so you need to plan ahead. Just because we have homework here that's due, this one is due on the 28th, you're not going to wait until the 28th to do the homework. You always want to be proactive. Make sure you're completing these assignments way ahead of time. I do post them early so that you have that opportunity. Okay, so always work ahead of time. I have to put a due date there, and I have to put a time, but I'm not guaranteeing that time is going to work for you. There could be, and everybody's on there at 10, then it's going to slow down the system, and you may not be able to submit your assignment. So you've been warned at the beginning of the semester to work ahead. So any email that I get where it's asking for an extension because whatever the reason is, I do not make extensions. Okay, so just plan for that, and always work ahead. Under quizzes and tests, I already have something in there, and I only have that there just so that you could see what it would look like. This isn't due until February 11th, but I just put your first quiz on there just so that you know what it would look like. Anything I'm assigning is at the top. Everything else is at the bottom. This is not for credit, and it tells you there. Sample tests and quizzes that are below this line, they do not affect your grade. That's just for your practice. Only what's up here, only the assignments that have a due date, those are for credit. All right, so that is available to you under homework. I've already talked about the survey that I would like for you to take. That's one of the questions that I ask you on today's lecture assignment. That lecture assignment that you're going to get during lecture is to take attendance, and one of the questions is about the survey. All right, so towards the end of class, this is what you're going to do. You're going to go and open up. This is how I take attendance for today's lecture. It says Lecture 1. I went ahead and made it available last night just because I knew I was going to be busy this morning. I just wanted to make sure it's there. But generally, that would open up during the lecture. So when you click on that, that's how it's just a 6-question assignment. It has questions about what we're going to talk about today. I gave you this number of times you can complete each question is 2. So you're not guessing. Either you attended lecture or you didn't. And so if you did attend lecture, then that should be enough. I gave you 2 attempts just because in case you by mistake enter something incorrectly, you didn't mean to. But you only get 2 tries at each question. Okay? So if you open up first question, it's asking you about the survey. Okay, so I mentioned during lecture that a class survey was due today, January 26th, before 11 p.m. How many points is it worth? So we talked about that. We said it was worth 10 points. Okay, and so you go through this, you're answering the questions, and that's how I will take attendance. Okay, those of you who are watching the recorded lecture, you do have says here until 11 p.m. Okay, so I'm going to go back to announcements. Are there any questions so far? All right, so most of the time what you're doing is you're just typing out your questions or your responses on this feature, the chat feature, and I'm scrolling down and I'm noticing that a lot of you just put your first name as your screen name. So I'm going to print a list of everyone who's in attendance, and that's how I keep track of who's coming to lecture. So you want to make sure you put your first name and your last name next time you log in. Okay? Aside from the attendance list that I print out, you will also have to do the assignment that I just talked about called Lecture 1. And so I'll show you again towards the end how to access it. Okay, so I think we are ready to start. I had something on my mind I was going to talk about, but I'm sure I'll remember before lecture is over. Introduction, make sure that you've posted your introduction on the discussion boards. You just go to discussions. And introduction, that's the first thing you have. There is a deadline for this. I do have students who are wanting to add the class. So make sure that you post your introduction, okay, to save your seat in this class until the next assignment, which is homework number 1. Any questions you have, make sure you post them on the discussion board. Okay, so I'm going to leave this up in case there are any questions. And I'm noticing it's about 12:48 and I'm still having students log in coming late. So you've already missed quite a bit of what I've said. So you want to make sure that you watch the recording part of this, okay? You need to make sure you watch the first part of the recording so you get everything. Okay, so I am going to go back to the whiteboard. Okay, so everyone should be back on the whiteboard at the beginning of class. I had typed this out, just letting you know how we're going to be interacting. I do get into the tendency of calling or asking questions during my lectures, and then if no one's answering, I start just choosing a few names. So I don't know if you've just logged in and walked away to go do something else. So that's why I keep asking questions, and if someone's not participating, I don't know that you're there, so I can drop you. And that's just the reason I do that is just because I need to know I need to know that you're listening to me and you're participating, because and then you could watch the recorded lecture if you can't attend during this time. So I just need to know who is actually there and who I can talk to. So, and it just helps me with my list of students here. If you do have to walk away because you have to go to the restroom or something, there is a button here. I just clicked it and it says away. So then I know you're away and I know you're coming back. So it's right over, there's the emoticons. So if you see how you're feeling confused, okay, I don't understand what's going on. So you can do that. That's just another way of showing me you're still there. Are you confused? Okay, so it just shows me what you're doing, if you're still there. If you have a question, please type it out. Once you come back, then you just click on that button again, the one next to the emoticon button, and you're back. If you have a question, raise your hand. That's the hand right next to the away button. Okay? All right, so we can go ahead and get started. I started this out just by typing a few questions up here, and it says, the first one says, statistics is what we do when we're trying to answer questions in the real world. And so questions like, does a particular drug, is that a cure for cancer, or is that particular drug effective in curing some disease? Is the economy rebounding? Is human activity accelerating global warming? So these are just questions that come up. And in statistics, what we do is we're trying to answer these questions. We go out and we gather data. And so we use this data to help us answer these questions. Okay. Now, in this class, I'm not actually going to have you go out and conduct your own survey, although you saw how easy that is because I did it through StatCrunch, the survey I sent you that I'm asking you to respond to. That was a survey that I did on StatCrunch. You will need to know how to use StatCrunch in this class because you do have 2 assignments, 2 projects that will be due. So in statistics, we collect data to help us answer questions that come up. And so these are just a few questions. To answer questions like this, we need statistics. And in statistics, we plan. We're going to plan an experiment. We have to know what steps we need to take. Okay, so I'm going to tell you where I'm at as I'm reading this. There we go. So we're going to plan studies or experiments. You need to know you need to have a plan. You need to know what steps need to be taken in order for you to gather your data. And so the next step is then to actually gather your data. And of course, when you're obtaining data in statistics, we want to make sure that that data is representative of the population in study. So the data has to be representative of the population that you want to study. So the sample is very, very important. The sample of data that you get is very important. Once you have that data, we want to organize it. We want to summarize it. And we organize it by using tables and graphs. We're going to be looking at that on Wednesday. So we are going to organize it using tables and graphs. And we're going to analyze it. We're going to interpret our data, see what's going on. And then we're going to draw conclusions based on that data. Now, the first part of the class is descriptive statistics. The last part is called inferential statistics. And that's our next. That's one of the slides coming up. So we're going to talk about the 2 types of statistics, descriptive and inferential. So the descriptive, we're just observing what's happening. We're just reporting what's going on in our data, but we're not actually making any conclusions. Inferential statistics, that's where we make our conclusions. Okay? All right, so I have this question here. So, can people become better, more efficient runners on their own merely by running? Or do you need weight training? How can people become more efficient runners? Can they do it just by running? So that's the question we want to answer. The population of interest, well, it just said people. So I'm thinking then it's all people. There's no group that was identified, so population of interest is all people. However, look at the sample. The sample that was obtained is just a group of adult women who recently joined a running club or a running group. So the sample is just adult women. So if the sample is just adult women, can I then, is that going to tell me what's happening in our population? Can I, right, you can't, right. No, because this sample is not representative of the entire population. We left out men, right? So the sample is not representative of our population. So all you could say, you could generalize about what's happening with adult women, but you can't say anything about your population that we wanted to look at. Okay, so the sample limits us. It's the sample of adult women. You can only generalize, make this generalization for adult women. Okay, so again, your sample has to be representative of the population. All right, so I just remembered what I wanted to tell you earlier. These notes are available on my stat lab. So if you go to lecture notes right underneath announcements, I have the condensed version if you don't want to type out a lot, if you don't want to print too many pages out. And then I have the full version, which is exactly what you're seeing right now. Then I have other documents that if we have time, I'm going to go over them. So every time we have lecture, this will be on the previous night or the morning of the lecture, so you have it there so you could follow along. And that sometimes helps people, so if you think that's helpful, then please use those. So I was talking about the two types of statistics. We're going to talk about descriptive statistics at the beginning. The first part of the class is descriptive statistics. Again, we're making no conclusions. We're just observing what's happening in our data. We're organizing, using tables and graphs. We're summarizing. We're presenting data with charts and graphs. But again, we're making no conclusions. Inferential statistics is where we start making conclusions. And that's towards the second, the second part of the class. Okay, so there's two types of statistics. So every so often we have something called a census, right, where we try to see how many people are in the country. So a census is a collection of data from every member of the population. So every time a census is conducted, do you think we actually have an accurate count? Yeah, probably not, right. So, and the reason we don't get an accurate count, it's very hard to collect, it's very hard to get to everyone, right? So when you try to look at every member in your population, it takes a lot of time. It takes a lot of money too, because you have to pay people to go out there and get all that information. So it's time consuming, it's very costly. And even after all that, when we do take a census, you haven't counted every single person, right? So it's still not 100% accurate. Well, in statistics, the way we study what's happening in our population is by taking a sample. It's very important how that sample is collected. It has to be representative of your population in order for your results to be meaningful. A sample is a subset of that population, and that's what we hope to obtain, a sample that's representative of our population so that we can make conclusions about what's happening in our population. And so here I just talk about the difficulty in trying to look at the entire population. So you have that in your notes. So these are just some of the problems that you run into when you actually try to look at the entire population. And so the procedures we're going to be looking at in this class is going to be such where we're looking at samples, and we're always using samples to help us understand what's happening in our population. So you can imagine then how important it is, how important the sample is. How do we come up with a sample? We're going to talk about sampling methods as well. And this, I found this online, and then I realized I was looking at it and I didn't totally agree with it. I gave them credit down here, but I thought this looked like an interesting way of explaining how data, how it works, or how we can classify data. And so towards the end, I'm going to come back to this, and I'm going to change something on this table, on this flowchart here. So we want to be able to classify our data, okay, in order to know what methods we can use to analyze our data. We need to know what kind of data we have. We need to be able to classify our data. And so that's what we're doing here. So the first thing I'm going to do is I'm going to take my data, I'm going to classify it. The first thing I look at is quantitative and qualitative. What is the difference between quantitative and qualitative? So that's the very first thing. Now, in my condensed notes, I don't have these two on there. So if you printed out the condensed version of my Chapter 1 notes, you're going to have to write this in. But this is available on the full version of my notes, everything that you're seeing here. And for those of you just joining us, I showed everyone where the lecture notes were located on my Stat Lab. So if you're coming in late, you want to make sure that you watch the first part of the recording, the first part of the lecture after the recording is available. So quantitative data, it says here they're numbers that represent counts or measurements. So quantitative data, they're numbers. Qualitative data is also called categorical data. And they can be separated into different categories that are distinguished by some non-numeric characteristics. So the definition, the way it explains it to us is this is numeric and this is non-numeric. So that's probably an easy way of looking at it. Quantitative is numeric, qualitative is not numeric. And there's, of course, exceptions to that. All right, so let me give you something else that's not here. The other thing that how you would distinguish between quantitative and qualitative, if it's numeric data, if you find the average of that data, does that give you anything meaningful? If it does, then it's quantitative. If it doesn't, then it's qualitative. So even though it's numeric, if you find the average of that data set, and it's not anything meaningful, it's not giving you any information, then it's not quantitative. So let me give you some examples here. I think I have a few. Okay, so take a look at this. I'm going to stop talking for about a minute. I just want you to look at this and try to label it as quantitative or qualitative using the definition I just gave you. All right, but I want you to think about this first, and then we'll go over it together. So yeah, just as a reminder that these notes are available on my Stat Lab. The tab under Announcements says Lecture Notes. And you could go on right now if you want to and print them out. Or you can just follow along and watch the recording if you need to see this again. All right, so I'm going to stop talking and then I'll come back. Okay, so now you've had some time to think about whether this is qualitative or quantitative. So the way the definition was written was that quantitative was numeric. But in addition to that, if you find the average of that data, and the average in statistics, we call that the mean. If you find the mean, it has to mean something. So let's look at telephone numbers. So it's numeric, definitely numeric. But if I find the average of everyone's telephone number, does that tell me anything? Okay, no, it doesn't, right. So that's not quantitative. Even though it's numeric, it's not quantitative. Telephone number is qualitative. All right, so that telephone number is going to be qualitative data. Again, even though it's numeric, when you find the average of everyone's telephone number, it doesn't tell you anything meaningful. So telephone number is more of its identification purposes only, right? That's the number someone dials to connect with you. The year that you graduated high school, what did you get for that one? All right, so we have agreement on that. All right, some of you say qualitative. Okay, so remember the year that you graduated high school, it's numeric, right? So what would happen if I took all of the years and I found the average to it? Well, that would kind of tell me like the average year that everybody graduated high school. So you have to decide whether you think that's meaningful or not. So for me, what that would tell me is about the average age of my students. So if I don't want to ask you your age, but another way I could ask your age is by asking what year you graduated from, then if I would find the average age that you graduated, that would tell me, about what your age is, the age of the class. So is that information meaningful to you? If it is, then you say it's quantitative. Okay. How about zip codes? Okay, good, qualitative. All right, so it's just identification purposes only. And then we have shoe size. Well, let's see, if it's numeric, so shoe size, if I was to find the average of everybody's shoe size, I guess that could be meaningful. I would find the average shoe size. I don't know how I would use that information, but average shoe size might be okay, so quantitative. All right, then over here we have the time that it takes students to finish an exam. I could find the average time it took the class to finish an exam. That would make sense. And then the last one, Social Security number. Okay, Social Security number, that's a numeric. That's numeric, right? But if I find the average if I take all of your Social Security numbers and find the average, it doesn't tell me anything meaningful. Good. Okay, so hopefully that kind of helps you with the definition, all right, between quantitative and qualitative. Now, when I write qualitative and quantitative, they kind of look the same, right? So at first glance, it's hard to know which one you're talking about. So look at what qualitative has. It's also known as categorical data. So instead of saying qualitative, you could say categorical, and it just makes it look different, okay, when you're writing it out. So categorical data. So if I circle my categorical data, qualitative, categorical is another way to talk about qualitative data. Okay, so what I've just circled is also known as categorical data. Okay, so let's move on. All right, so quantitative data can be broken down further. So now we're just focusing on quantitative data. So quantitative data is numeric. Not only is it numeric, but when you find the average, it has to be meaningful. That's how we know it's quantitative data. So it's broken down into discrete and continuous. Discrete data is finite number of values. So the number of children you have, it's a whole number. You can't have half of a child. The number of pets you have, the number of classes you're enrolled in. They have to be whole numbers. It has to be countable numbers. So continuous is data that's obtained through measuring. So anything that is obtained through measurements is continuous data. Someone's weight, height, temperature is continuous data. There are no gaps, no interruptions. All these are on a scale. So if it's a measurement on a scale, it's continuous data. Okay, so I'm looking at this again. It's the same one we were looking at before. We've already identified this as quantitative and qualitative. So now we're taking it a step further. And now we're identifying it as discrete or continuous. Now remember, in order for it to be discrete or continuous, it first has to be quantitative data. So do you see the ones that I marked here? Those are the ones we have labeled as quantitative data. So those are the only ones we could continue labeling as discrete or continuous. All right, so the year that you graduated high school. So let's write a couple of them here. So if we're just talking about years, we already know it's continuous. We already know it's quantitative data, right? So I'm just going to put a couple of years here. Now we're talking about years. So 2010 and a half, one thing you have to consider is whether it makes sense for you to say you graduated. Would anybody say I graduated in 2010 and a half? Or 20, right, that doesn't make sense. So if you're just looking at the year you graduated, you're just going to get these numbers, something similar to this. Okay? Now, if I had talked about, if the question had been your age, if I'm asking for your age or how long you were in high school, then that'd be different. If I asked you how long did it take you to complete high school, you could say it took me 3 years, 2 months, or you could give a time, all right? So how long did it take you to complete high school? That would be measuring time on a scale. But this one, the answers you're going to get are just years. So this one, you're looking at discrete. Again, had the question been asked a little differently, and I would be asking you how long it took you to complete high school, then that would have been a measurement of time, and that would have been continuous. But here you're just giving me a list of years. Okay, shoe size, that's the next one. So just go ahead and list them. And I'll start with 7. 7 and a half. Ooh, I'm getting a lot of continuous. I think you all agree on continuous. Anybody think it's something else? Seems like everybody, there's, okay, unanimous, continuous. Okay, so this is what I said. I said shoe size. So I did not say the length of your foot. because there's a difference. So what I said was shoe size. So shoe size comes 7, 7.5, 8, 8.5, 9. Had I asked you the length of your foot, where you actually have to measure your foot, that measurement comes on a continuous scale, right? But for shoe size, you only have these options. Now, if I were a size 7, if my shoe size is a size 7, that doesn't really mean that that's how long my foot is. That just means that a 6.5 probably is too tight and the 7 is more comfortable. So my actual length of the foot could be somewhere between 6 and 7. So when we're talking about shoe size, we're not talking about continuous data for that reason. Now, part of those emoticons, you could also give me a thumbs up or a thumbs down. If you are agreeing with what I'm saying, you can do a thumbs up, so you don't have to always type it out. But for shoe size, again, since they only come in those sizes, the full size and then the half size, there are gaps there. So between 8.5, there's a jump, right? Between 8.5 and 9, there's a jump. Between 8 and 8.5, there's a jump. It's not continuous. Okay, so for shoe size, it is discrete. Now, if I had been talking about the length of your foot, the length of the foot would have been continuous. Okay, so the length of your foot would have been continuous because it's coming from a scale. I think that was one of the questions that I asked you on the little assignment that you're doing at the end of lecture. I asked you to identify what kind of data shoe size is, and then what kind of data the length of your foot would be. All right, so the next one, time it takes students to finish an exam. So this is a measurement, right? It's measured on a scale. So correct, this is our only continuous one. All right, so only quantitative data can be further classified as discrete or continuous. Okay, so discrete data has jumps. They can only be whole numbers, 0, 1, 2, 3. It has to be countable. Continuous data comes from some kind of measurement. Height, weight, time, it comes from some kind of measurement. So it's continuous, there's no gaps or interruptions. Okay, so we're going to continue labeling our data. This is the next level for classifying our data. On the homework, I will be asking you to classify it. I'm not going to go through the series as I did here. It's either you're going to classify it as this, quantitative or qualitative, and then in a different question you're going to classify it as discrete or continuous, and maybe in another question you're going to identify it as one of these. Okay, so the question will be specific, and you'll only have the few options to choose from. So here, nominal, ordinal, interval, ratio are another way to classify our data. Okay, so here's the definition for nominal. So we just have data that consists of names or categories. And here are the colors, like red, blue, green, and yellow. It's just identification. Hair color, eye color, all that is just identification. Responses in a survey, there's just identification. There's no ordering to this. So nominal is identification. The next one is ordinal, so it's identification plus there's some order to it. So course grades, there is an order to them, A, B, C, D, F. The size of drinks, there's an order to it. It can be arranged. Interval data is data that can be ordered. However, this has the extra feature that when you subtract your data values, the difference between those data values, that's meaningful. So data at this level, when you subtract it, though the differences are meaningful. So also we know that interval data does not have a natural starting point of 0. Okay, so you can order it. When you subtract data values, that information is meaningful, but there's no natural starting point of 0. So what I put here is I put body temperature. Now, when I talk about body temperature, I meant that this is in Fahrenheit or Celsius, either measurement. So in Fahrenheit or Celsius. And when it's not indicated what measurement it is, we always assume it's either Fahrenheit or Celsius. Okay? So the reason this is interval data is because there's no natural starting point of 0. So heat does not start at 0 for temperatures. So let me go ahead and give you the scales here if you're not familiar with the different scales. Here we have Fahrenheit, and here we have Celsius. And as you notice, it doesn't start at 0. Now, water freezes at 32 degrees Fahrenheit and 0 degrees Celsius. But look at the measurement. It doesn't start at 0. Guess all molecular motion stops over here, so that's where our scale begins. All right, so this is any temperature in Fahrenheit or Celsius would be considered interval data. That's not true for the Kelvin scale. The Kelvin scale starts at 0. So that would not be interval data. So it's interval if it's Fahrenheit or Celsius because of the measurement. It doesn't have a natural starting point of 0. Now the other one is years. Years does not have a natural starting point of 0 because life did not begin at the year 0. All right, so you have life did not begin in the year 0, so years does not have a natural starting point of 0. So that would be interval data. Okay, so no natural starting point. All right, so that's what our interval data is. Body temperatures and years are 2 examples. Okay, and then our last one here is ratio data. So ratio data is any data in the interval level with the added feature that this one does have a natural starting point of 0. And that indicates that none of that quantity is present. So we do have a natural starting point of 0, which means that none of that quantity is present. So look at this, the cost of textbooks. What would it mean, because it has to be meaningful, what would it mean if your textbook was $0? Is that meaningful? Does that mean something? Does it tell us something? Okay, so you all see that. It does mean something, right? So cost of textbook. 0 means that's free, right? So it is meaningful. So if you're talking about cost of anything, then data that has to do with information that has to do with money would be ratio data because 0 means it's free or it doesn't cost anything. The distance traveled to work, distance that's measured, it's, you know, if you've traveled 0 miles, If you've traveled 0 miles, that means you haven't moved. It means something. Wow. So if your distance is 0, that means you haven't moved. All right, so it's a natural starting point of 0. Your weight, your age, again, ratio data. Okay, it has a natural starting point of 0. That means you don't weigh anything if you're 0. You don't weigh anything. I mean, it has to have meaning. That's where you start. Okay, so those are examples of ratio data, and now I have another exercise for you. This is a summary, and it's everything we've already talked about, but just in a different format. Ratio data has all of these checks because it provides all this information. Okay, the ratio data has a true 0, and we can multiply and divide values when we have ratio data. And so if you are looking at something that weighs 100 pounds and something that weighs 200 pounds, when it's ratio data, you can say this is twice as much as this. So you can compare objects. One that's 100 pounds, the other one's 200 pounds. For ratio data, one is twice as heavy as the other. So you have to make that type of statement. And so that's why it says you can multiply and divide values. Okay. So this might be helpful just to look at this checklist. So here's just a summary of what I've already talked about. If it's only categories, that's nominal data. If you have categories but you can order them, that's ordinal data. And then interval, you have differences but no natural starting point. Ratio, you have differences and a natural starting point. Okay, so this is where I said I was going to go back to that table that I talked about earlier. And so talking about the quantitative and the qualitative, I don't know if you noticed, but interval and ratio data, those were all numeric. Not only were they numeric, but if you found the average in your data set, that would be meaningful. It would tell you more information. So those would be quantitative. Interval and ratio would be quantitative for that reason. Now, the nominal and the ordinal. The nominal, that was categories only. So hair color, political affiliation, I mean, those are categories. So that would be qualitative. And then ordinal, again, they're categories. You can put them in order, but they have some category. But again, it's identification, although you could put them in order. So small, medium, large, you could put that in order. Okay, it's not numeric. It's a qualitative. So these right here would be qualitative. The two that I talked about here. Okay, now there might be, and I couldn't think of any, but when I looked at this diagram, first I thought it was a nice diagram. I thought I would use it. But here they have discrete, once they label it as quantitative and separated with discrete and continuous, then they say discrete is nominal and ordinal. All right, although if you have nominal is category only, so like eye color or hair color, that's not quantitative data. So that was I put a question mark here. That's what I don't agree with. I would put that over here. So nominal and ordinal. Now there might be some binary, those are zeros and ones. That would be fine. So I would have to think about an example of why it would go here, and I can't think of one right now. But what we've talked about, nominal and ordinal would go under qualitative because they are identification purposes, non-numeric. Okay. So I'll have to think about some examples of why it would be down here, but I disagree with that. I would put it under qualitative. Okay, so I am going, without having to show all that to you again, I'm going to try to skip to where I was at. There we go. Okay. So now you get this, and we're identifying it as nominal, ordinal, or interval. Looks like the same thing I've been asking you. So take a moment to now, after we talked about quantitative and qualitative, and after we've talked about discrete and continuous data, let's continue identifying our data, this time nominal, ordinal, interval, or ratio. So I'll give you a few minutes, and I'm going to stop talking, so you shouldn't hear me. Okay, let's see how you did. And there's a question, and the question reads, could there be more than one answer for each of them? There should be one, but there are good arguments for it being more than just one answer. And it all depends on what our goal is, what we're trying to look for when we plan an experiment or when we conduct some kind of study. So yes, there are a few that you can kind of argue two ways. And it all depends on what your goal is, what question you're trying to answer. Shoe size was one that we had a few questions about during my face-to-face class. That was one where we had good arguments for different classifications. Okay, so telephone number without, and I put without area code because I know that when you do have an area code, it kind of identifies what region you're in. I don't know if that's true with cell phones, but I know with landlines, the area code tells you what region you're in. So that one might have an order to it if you want to order it from east to west, moving from eastern part of the country to the western part of the country. It could have some order if you're talking about area codes, but if you're just talking about telephone numbers, I don't think there's any special. I don't think there's anything special about telephone numbers where it tells people anything about more than other than that's the number to call you. It's identification only. So that's how I see telephone numbers. They're identification only. So which one of these was just identification. Yeah, the nominal, good. Okay, now the year that you graduated from high school, we're talking about years, and you only have these 4 to choose from now. We don't have any of the others. Okay, so anytime you're talking about years, good. All right, zip codes. All right, so I'm getting a few ordinals and a few nominals. Now, you know zip codes, they identify where you live, right? But if anybody remembers, as you move from east to west, what's happening with the zip codes? So if you're in New York and as you move to the as you move west, is there any trend in the zip codes? If we do see a trend, then we can order them and they would be ordinal. So would you agree that if you look at zip codes going from the east part of the country to the west, that the zip codes keep increasing? So right now we're at 92020 in the 900s here. Yeah, so that's what I remember about zip codes. As you move from the east to the west, the zip codes increase. So it's possible to put them in order. It's possible to order them. So if ordering them gives you more information, then we could treat it as ordinal data. Okay, so that's what I would say here. So if there's an order to it, it can be ordered, then it would be ordinal data. And I believe that's how zip codes behave. Okay, shoe size. That one, I circled this. I put the bullet, I put it a little different because that one, you could kind of argue different things on that. So shoe size. So there's an order to it. Would you agree? All right, so I'm getting ratio. Okay, I'm getting a lot of answers on here, and that's because you can argue a lot of things here. All right, so shoe size. There's an order to it. Definitely there's an order to it. Okay, so we can check off that there's an order to it. Okay, I'm going to put it on the side here. All right, so is there a question that I missed here? Okay, so, all right, so yeah, so shoe size, you could definitely say it has, or there's an order to it. You can order it, definitely. The next question was interval. So is there a difference between two shoe sizes? So if someone's a size 12 and I'm a size 6, if I subtract those two shoe sizes, does that give me any information? Because if it gives us meaningful information, then we could check off that it's interval. So if I have a shoe size of 6 and someone else has a shoe size of 12, I subtract those two, and if the difference is meaningful, if it gives me information, then I want to say it's interval data. Now, I don't know if I take, if I actually measure that, if two sizes of size 6, is that going to equal a size 12? Because if that's the case, then there is meaning when you subtract two data values. All right, so if there is meaning when you subtract the two data values, then I would say it's interval. Now you understand that nominal, it identifies what shoe size you are, right? So ordinal has the condition of nominal as well. Interval has the condition of ordinal and nominal as well. Okay, so when you say interval, you're saying that it has order to it already. Okay, so I could say this is interval. Now the other question, and the reason I put interval in there is because if you subtract two shoe sizes, if that information is meaningful to you, then you want to say it's interval. Okay, so the other question is, could it be a ratio? I don't know about ratio. Does it have a natural starting point? So 0, yeah, no one can have a size 0 shoe, correct. But remember that 0 is the natural starting point and means that there's none of that present. So somehow on a scale, we start at 0. Right, 0 would be no shoe. There's nothing there. So if we look at the definition, let me go back. I don't know how far I have to go back, but I think it's this one. So it has a natural starting point of 0, and that means that there's none of the quantity present. So there's nothing there. It's a starting point, exactly. So in that case, we would say then ratio. Okay, so I know there is not a size 0 shoe, correct? But what 0 means is that it's a natural starting point. It means that there's none of that present. So always go back to the definition, definitely. Okay, the time it takes a student to finish an exam. Okay, sounds like there is agreement on that one. And then Social Security number. Yeah, Social Security number is just identification purposes only. Now, I don't think we can order Social Security numbers. Now, I know they get assigned by when you apply for a Social Security number, but I don't know that we would get any information by ordering Social Security numbers. So yes, it's just nominal. Identification purposes only. Yeah, so Stephen says they have, right, there's a meaning. And I'm sure, I mean, if you get more information by ordering them, if that gives you more information, then you would say ordinal, but we need to figure out what that was. Right. So if you see what everybody's typing out, true, that could be it. So that's the thing. You have to see if that's meaningful to you and if it's something you can organize. So would it make sense for you to be able to organize that? So if that is true, then if it gives you more information if organizing them gives you more information, then that would be an ordinal. But if it doesn't, then you would stick to nominal because it's just identification purposes only. So on this one, because I don't have more information, I would have to say nominal. Okay? All right, so let's go ahead and talk about symbols. We have different symbols representing the different measurements that we're taking. And it all depends on what you're looking at. If you're looking at your population, measurements from the population have certain symbols, but measurements from a sample have symbols that are different. So this is what I'm looking at. If your measurement is coming from the population, then it's called a parameter. And parameters are Greek letters. This parameter is known as mu, and mu is the mean, which we also call the average. So if you're finding the average in your population, you would say mu equals and then tell me what the average is. If it's a measurement from a population, it's called a parameter, and we always use Greek letters. And the way I remember this is parameter starts with P, population starts with P. So a parameter comes from a population. A statistic is a measurement that comes from a sample. And the way I remember that is Statistic starts with S, and sample starts with S. So a statistic comes from a sample, and it's just a measurement of what's happening in your sample. And for that, we use Roman letters. Now, the symbol for the average in a sample, which we call the mean, is X with a bar over it. In a sample, that is the symbol we use for the mean. So based on symbols, you should know whether it's coming from your population or your sample, all based on what the symbol looks like. If it's not stated or clear from the reading, whether you have a population or a sample, we always assume we have a sample. But if you're given the symbols, you should always know whether you're looking at the population or a sample, just based on what the symbol looks like. Okay, so this part, once we've classified our data, which is what we were doing before, we were classifying our data, and now I'm talking about the different symbols that represent the measurements from a population or from a sample. The next thing we're going to be looking at is how you gather your data. How do we obtain the data? This is a very important part of it, because remember, our goal is to make sure our data is representative of our population. So very important how we obtain our data. Okay, so we have two different types of situations here. We have observational study. In an observational study, you're just observing and measuring specific characteristics without attempting to modify the subjects being studied. So you're just measuring, you're not trying to modify anything. The experiment, you're actually applying some treatment and then you're observing the effects. So maybe there's a certain drug that you're trying to see if it's effective in helping patients lower cholesterol levels. Well, you're applying some treatment to that. You're maybe taking certain individuals, giving them the drug, and then taking another group of individuals and giving them a placebo, and then trying to see if there's a difference between the two groups. But you're applying some treatment and then observing its effect on the subjects. So we have to plan how you're going to collect your data, what scenario you're going to find yourself in. Are you just observing, or do you actually want to apply a treatment? So it's very important to have a good sample. Our sample has to be representative of the population that we're studying. Okay, so here we have a random sample, and the random sample are members of the population that are selected in such a way that each individual member has an equal chance of being selected. So every member in your population has to have the same chance, an equal chance of being selected. Now, a very low-tech way of doing a random sample is if I wrote everybody's name on a piece of paper and put it into a hat and then just mixed it all up, and then I just drew a name. That's a very low-tech way of getting a random sample. And the reason I'm doing that is everybody's name had an equal chance of being selected. Okay, so that would be one way. Now, nowadays what we do is we have computer programs, and we have the computer select a random list of names for us. Social security numbers, ID numbers, maybe telephone numbers. It can select a random list, and that's how we can decide that's how we can obtain our sample. All right, so that's a random sample. Every member in the population has to have an equal chance of being selected. Now, a simple random sample is a little different. A simple random sample, subjects are selected in such a way that every possible sample of the same size, let me underline that, of the same size, has the same chance of being chosen. So every sample of the same size has to have an equal chance of being selected. So in my face-to-face class this morning, we have let's see, I'm just trying to, we have 6 rows of desks. So these are my different rows, and I'm in the front here. So 4, 5, one more. So I had my different row, and people are sitting here. I think we had 8 students in each row, but I don't have enough space here, so I'm just going to put 4. Looks like I was able to get 4 desks in there. Okay, so I'm looking to select a sample of a certain size. So we'll just, for the purposes of what I did here, 4 is a very small sample. We wouldn't want to do that, but that's what I was able to get here. So say that I'm selecting, I'm trying to select a sample of 4. If it's a simple random sample, every row in this classroom has to have an equal chance of being selected. So if I have, you can see how great my drawing skills are here, not very good, but if we have a die, you know how a die has sides, that one will have 3 dots, 6 sides, yeah. I have to put 2 on here. Okay, so I have a die, and that's supposed to be a die, in case it doesn't look like one. If you have a die, it has 6 sides to it, right? Well, I have 6 rows here. If I were to roll that die, would everyone have an equal chance of being selected? Would every row there have an equal chance of being selected if I make my selection based on what comes up on the die? Assuming it's a fair die, right? So assuming that it's a fair die, yes, we can say that. So assuming that it's a fair die, then every row had an equal chance of being selected. And so that's all that a simple random sample tells us, is every group has to have an equal chance of being selected. They have to be selected in such a way that every possible sample of that size has the same chance of being chosen. That's a simple random sample. Okay, now of course, we would love to have a random sample. Not always possible, but that is what will hopefully give us a sample that's representative of the population. There are other sampling methods or other sampling strategies. Now I just noticed that I put systematic sampling here twice. I didn't mean to do that. It should only be there once. So sampling strategies, these are just different other, these are other strategies that are used, but they're not random samples. Systematic sampling, you take every case member in your population. That's one way of obtaining your sample. You have to be careful if you're looking at, if you go into a factory and you're trying to get a sample of what's being produced in there. It could be that the machine is producing every second item. It's, there's the fact every second item is being produced in a certain way, and there could be some kind of adjustment that needs to be done so that that's not happening. So in that case, if you're doing systematic sampling, your results are not going to be representative of what's really going on. So it's not always, there's certain situations where you don't want to use these sampling strategies, but that's just one, systematic sampling. And of course, convenience sampling, we see this all the time. People standing, walking around in the mall asking you to fill out a survey. That's a convenience sample. Again, not representative of the population. We have others, stratified sampling. This is where you divide your population into 2 groups, and then you draw a sample from each of those groups. And then we have cluster sampling. You divide your population into sections, which are known as clusters. And then what you do there is you randomly select some of those clusters. But when you randomly select those clusters, you have to choose all the members from those clusters. So there's different strategies for collecting samples, and those are a few. So what I did is I went ahead and I gave you a list of options here. So I want you to read through this and see if you can identify which one's which. After reading through the definition, see if you can match this up. Okay, so I'll give you a few minutes to look through this. Okay, so let's see how you did. So what did you get for A? What is the consensus on A? Is it 1, 2, 3, or 4? I'll write down what the majority of you say, and then we'll look at it. All right, so getting a lot of 4s. Yes? Okay. All right, so why is it nobody disagrees with that, so I don't have to go any further on that? Okay. All right, so number 4, so A is systematic sampling. You're obtaining every 20th student on the list. Okay, how about B? So no disagreement on that one either. Looks like everybody thinks it's 1, yes? Okay. So a statistics instructor teaching 300 students wants to determine if the class understands different sampling methods. So she just selects a sample of 10 students, and they're all from the first row, right? Because they're all probably closer. So yeah, that's convenient. All right, how about C? All right, so a lot of 2s. So 2 is the stratified sampling. So to determine employee satisfaction, corporate management for Target divides all stores into 3 regions: the West Coast, the East Coast, and the Midwest. Then 100 employees are randomly selected from each region. Okay, so here's the key. It says randomly selected. Had that been cluster sampling, you would have taken all of the individuals in that group, right? But it says randomly, so good. That would be 2. And I guess it leaves us with the last one, and that one must be 3. Yes? Okay, Sharp Healthcare wants to administer random drug tests in its hospitals. An outside research company randomly selects 4 hospitals and then drug test every employee. So once you divide them into groups, if you're looking at every one, in that group, all members, that's your cluster sampling. Good? All right. So that's what homework 1 is. You should have a lot of definitions. You have to match things up. We're actually going to be looking at data in Chapter 2. I do want to make a note about certain things that you need to be aware of. So you see it, everywhere, and online, in the newspaper, different articles, even news in the news. You see these polls that they're asking, what is your opinion? So this is one that I pulled off somewhere. It says, which part of living in San Diego caused you more financial strain? So it was a poll that says cast your vote. All right. So when I saw this, okay, first thing, they collect your responses and then they report on it. So the results of a poll like this, are these results representative of everyone living in San Diego? What would you say? Right, it's not representative. Why? Because it's not a random sample. First of all, it's not representative of the population. If it's not representative of the population, you can't generalize about how all of San Diego feels, right? So this is a convenience sample. Not a convenience, I should say. This is a voluntary response. You choose to answer the questions or not. It's a voluntary response. And it occurs when the sample consists of people who volunteer to respond. And usually they have strong opinions on the issue, either way. Okay, so voluntary response is not representative of the population. Of course, we've already talked about convenience samples. Now, the other one is non-response. Now, you may have a list of people to contact, and that list is representative of your population, but then what happens is people will not reply to your survey. If you have only a small fraction of the randomly sampled people who choose to respond to a survey, that sample may no longer be representative of the population. So we have a lot of incentives sometimes when you're asked to participate in a survey. One time I ended up getting an envelope in the mail, and it had a survey, and then they put $1 in there just to kind of help you, at least to see if you could fill out the survey and return it to them. So sometimes companies or different organizations, they end up putting money into along with the survey so that people are hopefully more willing to help out on the survey. But it's so important if you're selected to answer, to be part of a sample, it's making sure that you are able to participate, because what happens if people do not participate, then the sample is too small and it's no longer representative of the population. Now, what did I do for you what did I do in this class to have you respond to my survey? Let's see, what did I do? Well, I went under announcements. So was it extra credit? No, not extra credit. It's worth 10 points, which is what a quiz is worth. So it's not extra credit. It is part of your grade. So I made it 10 points. Okay, so it's worth the same as a quiz or a homework. And once I have everybody's response, I'll put that into the grade book. So the survey that you were asked to fill out, that is due today, you want to make sure that you do it. It's easy points, and it is 10 points. It's not extra credit. It's part of your grade. It is 10 points. So that's what I did to hopefully get you guys to fill out the survey, and that's the data that I'll be working with. So don't forget to go and do that. And of course, you're probably aware that there are many bad practices and people or organizations trying to use statistics to prove, to convince you of something, right? So here, some bad practices I talked about: voluntary samples. That's not going to give you a sample that's representative of the population. Using small samples. The conclusions from a small sample are not going to be representative, again, of the population. So any result you get from that is not meaningful at all. And here's another one: distorting graphs to convey information. So let me show you that one. So these two graphs, when I look at them, wow, this one really catches my attention right here. Look how much higher that red bar is from the blue one. So Nevada, what is this? Personal income per capita. Wow. So California is making a lot more money than in Nevada. So that's what, if I'm just looking at the graph, that shows that there's a huge difference in personal income per capita between California and Nevada. But there's something here that's out of place. This is done over and over again, and if you pay attention to this from now on, you'll catch a lot of these mistakes. And they're not always mistakes, actually. I mean, this is done for a reason. So I'm wanting you to look at this and see what's wrong with the one I circled. Well, if you said that it needs to start at 0, you're correct. We need to start our scale at 0. So look at what they did here. They started at 30,000. Okay, so you don't want to do that. You want to make sure that it starts at 0. All right? And exactly, I agree with the comment that you're making. It makes the reader believe that California's income is significantly higher. So that is an example of how statistics is misused to convey someone's point of view. They want to convince you of something. That's the type of things that you would see. So you should start at 0. Now, when you look at the first graph, of course, yeah, there's a difference. California's personal income per capita is higher than Nevada, but it's not. The difference is not as it is on the right side. All right, so you want to make sure you're always starting at 0. Don't try to distort the graph. There are many other ways of misusing statistics. I just talked about a few. All right, so I have, I think we might have already talked about this, but I had an exercise here for you. I already talked about this one, right? Telephone numbers in a phone book. Was that qualitative or quantitative? I think we did talk about that one, right? Nothing. There's nothing meaningful that comes out of finding the average of everybody's telephone number. So although this is numeric, it's not meaningful. So it's, okay, let's see, I'm just going to see if there's some I haven't covered on here. The daily high temperatures for the month of June. Okay, temperature. So I didn't tell you what scale it was. So what scale do we assume we're talking about? If I don't tell you, what do we assume? Right, it's not Kelvin, it's either Fahrenheit or Celsius, correct. So you're either looking at Fahrenheit or Celsius. Now it doesn't matter whether we are looking at Fahrenheit, Celsius, or Kelvin here. here because I'm not asking you whether it's ratio or interval, but only if it's qualitative or quantitative. So in this case, of course, it's quantitative. If I continue to ask you more about this between ratio and interval, then Fahrenheit, Celsius are an interval scale. The percentage scores of a class on an exam. If you find the average, it's meaningful. So again, quantitative. I'm just trying to see if there's any that I didn't cover already because I did have this. Okay, this is one I didn't cover, I don't think. So we have the player numbers on a baseball team. The player numbers on a baseball team. Yeah, that's identification purposes, right? Okay. How about this one? That one's ordered. Okay, good. These are just classification, right? Just classification. Okay, so nominal. Just names only. Okay, this one's interesting. IQ. Nominal, ordinal, interval, or ratio. I had to look this up to see if it had a natural starting point. And you can see here that 0 doesn't mean no intelligence. Right. 0 must be a potato. Okay. So in this case, yeah, it doesn't have a natural starting point of 0. So here 55, mentally inadequate, so that's probably like the lower. Yeah, so most of us fall within this range. This, by the way, is a normal distribution, which we will talk about later during the semester. Data that has a bell-shaped curve is data that's normally distributed. So we're going to come back and talk about this. But right, you all said this was, I think, interval, right? There's no natural starting point of 0. Now, this is assuming that if I have IQ levels and I subtract, that gives me some information. So is someone who has an IQ level of, or IQ score of 100 and someone who has an IQ score of 200, does that mean that the person who has an IQ score of 200 is twice as smart or twice as intelligent as the one who has an IQ score of 100? Because that's what ratio data is, right? That's what ratio data does. In this case, it's not ratio. So interval sounds good. So if you take 2 and you subtract it, this IQ score is 15 higher than the other one. So it gives you some information. So definitely not ratio. Intervals looks like that'll fit. So this one, you have to classify your data by level. There's an order to this. Yes, I had a few ordinal, a few nominal. So let's say maybe a company's U.S. sales staff is splitting among the following regions. So we have the Northwest, the Southwest, Southeast, Northeast. You could order that. Yeah, I could argue that you could order that. There is order to it if that gives you more information to order it, but I think for this one might be identification purposes only. Yeah, so I'd go with nominal identification purposes only. I don't know if I would get more information if I ordered these. Which one would go first? But if that gives you more information, then you would do that. But I think this one's just nominal. Okay, we talked about temperatures, and this one I told you Celsius, but if I don't say it, it's Celsius or Fahrenheit. Those, you assume it's Celsius or Fahrenheit if I do not tell you what scale it's on. So temperatures are interval, correct? And just to remind you, the scale. And that's the same scale I had shown you before. So interval. Okay, so this is what I'm going to do. Those of you who feel like you still need more practice on identifying your data, and sometimes you feel like you know it already and then you get to a problem and you get it wrong, and so if you feel like you still need more practice, when you go to My Stat Lab, just go to Lecture Notes. And I gave you some more, this is a worksheet, classifying data. And so I'm going to open it up. This is actually a game. You don't have to look at it as a game, but if you want to play it, you can. This is what you're really paying attention to. So these are a lot of scenarios, and you have to identify, and it's only having to identify it from nominal, ordinal, interval, or ratio. Okay, so that's what you're identifying it as. There's one from the answers that I'm going to post that I disagreed with, and that's measurement of sea level. So for that one, because there's two ways of measuring it, so whether or not it has an absolute zero is questionable. But that was the only one that I kind of disagreed with. So if you feel like you need more practice, this is something I would definitely go and do. Something else that I have here for you is random sample versus simple random sample. That's something students usually struggle with. You'll notice that in this class there's a lot of reading. So to be successful in this class, you need to make sure you're reading the material. Make sure you're going back to the textbook and reading the chapters, reading all the different sections. And of course, going through everything that I post and read through that. So this is something where you're telling me whether you have a random sample, and then if it is a random sample, you have to tell me whether it's a simple random sample. So just read through this and see if you could see how you do on this, and then I'll go ahead and go through the answers at the next lecture, the next time we meet. Okay, so now this is what you're going to do. You are going to go to homework, and hopefully everybody has their has the My Stat Lab open, but you're going to go to homework. And right now I am printing a list of the participants because I need to know I like to know who's attending. So I'm printing out a list of all of you who are here. A reminder, you need to make sure that you put in your first name and your last name as your screen name. Otherwise, I do not know who you are. So next time you log in, please use your first name and your last name as your login. Now, the advantage of attending a live lecture is that you can stop me. If I'm not making any sense, you could stop me. You can, if you disagree with something, you can ask for more clarification. If you need me to do another example, I can do that. So with a live lecture, you have more control of what's happening versus a recorded lecture. So please take advantage of this. I don't do it every semester. So please take advantage of this format, okay? All right, so I am going to stop the recording, but I am going to continue with those who are live. So in order for me to know that you watched the lecture, when you go to homework, you're going to click on Lecture 1, answer those questions, and then you have credit for the lecture. Okay, so at this moment, I'm going to stop the recording, and then I'm going to continue with those who are attending live.